I recently did a hands-on lab with our HP 3-par system. In the first part, what I did was I basically created some virtual volumes. I created both thick and thin virtual volumes and showed how to do that with the Inform Management Console. Today what I want to do is focus on the zero detect feature that comes through the ASICs that's in the HP 3-par array. Now, what is zero detect? Zero detect is basically an ASIC that watches the stream of data, and when it sees a number of zeros coming, it basically doesn't write those to the disk drive, saving space. This would be a great feature for somebody, for example, if they were going to convert a volume on an old storage system to a new HP 3-par array. It would save that space. So let's look at how we do that. Okay, so the first thing I'm going to do here is enable zero detect for this virtual volume. It is normally not enabled, so I'm going to go into the virtual volume, click through here, and you can see I've now enabled zero detect. Click next, and here's a summary of that virtual volume, which is again a thin provisioned virtual volume that now has zero detect turned on. Okay, so now I have that turned on. I'm going to speed up the video here a little bit because what I need to do now is make this virtual volume visible to my Windows-based host that I'm using in this hands-on demo. So I'm going to go through that process now, going into the Windows Management Console, and I'm going to basically make this virtual volume visible to the OS. You can see there it is, disk 1, 10 gigabytes, and now I'm going to go into the simple Volume Manager wizard and make this my E drive within this demo. So from now on in the demo you'll see the E drive, and that will be this this virtual volume that we've got attached to my host from a 3-par perspective. Okay, so there you can see it again. Now what I want to do is take a file that is all zeros, and I'm going to copy it to my E drive. So here's the file. And again, this is just basically a 2 gig in size, all zeros, and I'm going to copy it to basically replicate, what happens when zero detect sees a thick volume that's just full of a bunch of zeros. So we'll just let this copy, and we'll watch what happens here. So first of all, let's look at an OS perspective. The copy's done, so let's look at the properties of the E drive, and you can see there's a 2 gigabyte file as far as the OS is concerned. But let's go back into the Inform Management Console, and you can see it's basically saying no space has been used. So no space has been allocated because it used the zero detect to condense that space and not actually write it to the disk. Now I'm going to go back into this virtual volume. I'm going to turn off zero detect, use the same process I used before. Frankly, this probably would have showed better in the demo if I'd have done this in the opposite order, show you the zero detect off first and then go back and copy a second file with zero detect turned on. But I think you'll still get the idea here. So now we're going to do a copy of a second file of all zeros to my E drive with the zero detect turned off, and now we'll see the effect that that has. So I'm going to paste the file, and now that's kicked off. Now what I would expect is that from an OS perspective it's going to see now I have about 4 gigabytes consumed. So it's copying the file, and you can see on the Inform Management Console you can see that I've now consumed some space. Just about done. There we go, file copy's done. Let's go first and look in the E drive from a OS perspective, and you can see yes indeed it thinks it's copied about 4 gigabytes of data. And now if we look at the Inform Management Console, we can see that we are now actually consuming space because of having turned off zero detect. So now you can see the difference between zero detect on and zero detect off, and there's definitely now space being consumed. So I have one more file I want to copy just to give you an idea of how this all works together. This time this is going to be a file of random data, so this is not going to be all zeros, so we're not really going to see the zero detect ASICs have an impact here, but just to show you we're going to go ahead and turn zero detect back on. So there we go, we've got it on. We're going to click next, and now you can see kind of a summary of the virtual volume that we're using here, and we'll go into our drive that has the files that I'm using for this lab to copy from. There it is. And there you can see the random data file. It's 2 gig in size. And again, opposed to the other two that I've copied to this point, those other two were all zeros. This one is a random data set. So I'm going to copy that file. There you go, the copy's kicked off. So one thing that might be worth just mentioning briefly as this copy happens is that an advantage that 3PAR has within a VMware environment is around this zero detect. VMware recommends you use something called eager zero thick VMDKs, and that basically means that we write all zeros in a VMware VMDK to basically zero out the VMDK before you use it. Hopefully you can see very quickly that with all zeros and with our zero detect turns on, this makes these VMDKs in a VMware environment using eager zero thick very, very efficient. So now you can see that file copy has completed. From an OS perspective, we've consumed 6 gigabytes of data from an OS perspective. So if you're a math whiz, you may be looking at the amount of reserve space and user space here and be thinking that this doesn't quite add up. Well, here's what's going on. We don't pre-allocate space with the 3PAR array. What's happening is the system is autonomically adapting to the fact that we are writing a lot of data in a very short amount of time. So it's going out and grabbing space that it thinks it's going to need given the kind of behavior it's seeing. So this is the autonomic nature of the 3PAR system. It's kind of what you would expect an autonomic system to do. Do one more thing here. What we're going to do is we're going to delete these 3 data files. And I want to show you how we might recover this data. Now, I'm obviously in a Windows environment, so to be able to reclaim capacity in a Windows environment, there's a couple ways you can do that. And there you can see I've got zero space on my E drive. But as you see, I go back here, I haven't actually reclaimed that space from a virtual volume standpoint. So again, in a Windows environment, there's a couple ways of doing that. There's utilities like Semantic Storage Foundation that has the capability to go do a SCSI command called write same, which will put zeros out on the drive and basically reclaim that space as being empty. Or the other way we're going to do it here is we're going to use a native Windows command called sdelete. So sdelete basically does the same thing. It goes out and reclaims the capacity by writing zeros in the free space of the file system, and sdelete is a tool that we'll use to do that with. So there, sdelete is kicked off, and you'll watch the what happens here with the amount of space being consumed. Now what I'm going to do is I'm going to skip forward in the process. This took about 2 minutes to run the sdelete command, but you see now I've kind of condensed that and it's finished. And as you can see over on the 3PAR management interface, you can see that we now have recovered all that space and we're down to 0 space used. So hopefully if you found this demo useful, if you want to learn more about HP 3PAR, go to www.hp.com/go/3PAR. You can find me on Twitter as HP Storage Guy. You can find my blog at www.hp.com/storage/blog. Until next time, thanks for joining me.